Hello friends, welcome to MG Engineers Academy. Today we are going to discuss the examples based on the shifting theorem. In last session we discussed the shifting theorem. So today we are going to have some examples. Laplace transform. First thing, what is first shifting theorem? Laplace of e raised to t f of t is equal to f bar of s minus a, right? This is the first shifting theorem. And what is the Laplace equation? Laplace of f of t to 0 to integration 0 to infinity e raised to minus st f of t dt. Right. Now today we are going to have the example based on this first theorem, the shifting theorem. So here is a trick how you can able to identify whether we have to use first shifting theorem or not. Simple trick is that whenever in example you see the e raised to at term or e raised to anything, right? If you see such kind of term in the equation or the function, then you must use first shifting theorem. This is the one simple trick which you have to remember so that it will be easy for you to identify whether we have to use first shifting or not. So here is the first example. E raised to minus 80 sine 80, right? Now what we have to do, we have to find Laplace for this e raised to minus 80 sine bt. So you can, by simply observing this function, you can see here e raised to minus 80 term is mentioned, means we have to use first shifting theorem. That's it. Now what we have to do, Laplace of e raised to minus 80 sine t sine t, right? Now we know Laplace of sine bt. So let me recall some the equation which we discussed in first two sessions. Laplace of sine t to a on square plus a square. This is the Laplace of sine 80 we have, right? Only term is instead of a, here we have b as a constant. So what will we get? So we know, and right, we know Laplace of sine 80 is equal to a square plus b square. Now in first shifting theorem, now this is the term which we knew about sine bt, right? And the first shifting theorem, we have Laplace e raised to t f of t is equal to f bar s minus a. Now when e raised to at is there, then we have f bar s minus a, right? Similar way, only simple change in this problem is that we have here minus 80, right? So we just need to use the logic here. When you have minus 80, then only small change will be there. You are going to use s plus a. Okay? So Laplace of is to minus 80 into f of t is equal to f bar of s plus a. That's it. Only simple changes when you have the minus sign here, then you are going to change the sign of this bracket inside the term s plus a. When it is positive term, then you don't need to worry. You have to use as it is s minus a. So now by applying first shifting theorem, what we have to do here, only in the place of s, right? In the place of s, you have to put value of s plus a. Means this case we will have Laplace of e raised to minus at sin bt is equal, right? B upon s, the value of s is s plus a, s plus a bracket square plus b square. That's it. And this is the answer of your function. The Laplace of e raised to minus at sin bt will be b upon s plus a bracket square plus b square. Means in first shifting theorem, you have to replace the value of s by s minus a or s plus a. And that's it. No need to change anything. Okay, I will go to the second example now. Now we are moving to example second. E raised to minus 80 cos of bt, right? You have to find the Laplace for e raised to minus 80 cos of t. Now, small trick. What is trick that? It is multiplied by a raised to minus 80. So we have to use first shifting theorem. It's a small trick. Now, what we have? We have the Laplace of cos bt is equal to. Now, what we knew, Laplace of cos of 80 is upon plus s square plus s square, right? Similar way, only small change is that here we have b, the equation which we have standard equation, the standard formula. Here we have a, that's it. Small changes there. So the rest will be the same. It's upon s square plus b square, right? Now by first thing theorem, what we will get is the first shifting theorem. Laplace of h to at f of t f bar of s minus a. Now we have here minus, right? Minus 80. So the small change is that you have to the changing the sign bar of s plus a. Now we have to put s plus a in the place of s. Whatever value we have s, we are going to put s plus a. Now Laplace of s to minus 80 cos of bt. Here we have s. So what we are going to put s plus a upon s plus a bracket square plus b square. That's it. This is the answer for Laplace e raised to minus at into cos bt. So we are moving towards next equation now. Third equation. Now we are going to third problem. Third. What is third? Let me take now e raised to minus at sine hyperbolic bt, right? What we have to do? Now in this case, we are going to use first shifting theorem. Why? Because here we have e raised to 80 into sine hyperbolic bt. So it is multiplied by e raised to 80. Okay. Laplace of to minus 80 sine hyperbolic t, right? Now we have what we have. What is the value of sine hyperbolic 80? Hyperbolic 80 have a upon a square minus a square, right? Only small change is that we have here sine hyperbolic bt. Here we have sine hyperbolic 80 on that change only. Here we have b. We have Laplace of sine hyperbolic bt b upon square minus b square, right? A square minus b square. Now by applying shifting theorem. What is the first shifting theorem? Laplace of e raised to 80 of t the bar of s minus a. The change is here we have minus sign, so it will be bar of s plus a. Only you are going to change sign to plus. So now what we have to do? We have to put s plus a at the place of s. So b upon s plus a square minus b square, right? S plus a and s plus a bracket square minus b square. This is the value of sine plus of e raised to minus 80 is to minus 80 into sine hyperbolic pt, right? This is the third example. We now we are going to fourth example. E raised to 40 cos of hyperbolic pt. So hyperbolic pt, right? Now what we have to do? We have to find Laplace is to 40 into cos of hyperbolic pt, right? Now what is the trick? It is multiplied by e raised to 4, so we have to use first shifting theorem. Now here we have cos of hyperbolic 5t. Now what do we have? Laplace of cos of hyperbolic at equal to s upon s square minus a square, right? Now what we can write? Laplace of cos of hyperbolic cos of hyperbolic phi u t equal to, yes, s square minus phi u square equal to s upon s square minus 25, right? Now, what we have to do to apply per shifting theorem by applying first shifting theorem. What is the per shifting theorem? Class of e raised to at into f of t is equal to f bar of s minus a. Now, in this formula, we have only e raised to at. So here no need to change any sign because it's a positive sign, so it will be f bar of s minus a. Now, what we have to do? We have to put value of s is equal to s minus a, right? So what will the s minus a? Here a is 4 now, right? So what we will get? Laplace of e raised to 40 into cos of hyperbolic 5 t is equal to, yes, what is the value of a? Sorry, s minus 4, s minus 4 bracket square minus 25. We simplify it, can get s minus 4, right? S square minus 8s plus 16 is 25. For the simplification, what will we get? S minus 4 upon square minus 8s minus 25 and plus 16. It will be get minus 9, right? So that's it. This is the answer for Laplace of e raised to 40 into cos of hyperbolic 5t. Now we are going to next example. Example 5. E raised to minus 2t to 3 cos of 6t minus 5 sine of 6t, right? We have to find Laplace for this equation. What is the trick? T is the multiplied by a raised to minus 2t, means we have to use first shifting theorem. Now, what we need to do here, we have, we know value of Laplace cos 80 and value of sine 80. Right? What is that? Laplace of cos 80 is equal to s upon square plus square. Laplace of sine 80 is a upon the square plus a square, right? So what we need to do, Laplace of is 2 minus 2 in 3 cos of 60 plus 5 sine of 60. Now what we need to do, we knew the value for cos 60 and sine 60 because it's a standard formula. So what I can do, first what I will do, I will apply linearity property. What is that? The Laplace of 3 cos 60 minus 5 sine of 60, right? So after applying linearity property in this equation, what I will get? I will write 3 outside because it's a constant. Laplace of cos of 60 minus, I will keep 5 outside because it's a constant, sine of 60, right? So what I will get here? System throws, wait for a second. Okay, 3. Laplace of cos 60 will be s s upon s square plus a square. A is 636 minus 5 into sine 60 sine a upon s square plus a square, 6 upon square plus 36, right? Here what I can do, here 3s upon s square plus 36, right? Minus 5 into 6, 30 upon s square plus 36, right? Now what we have? Right? So here what do we have? Base is common, means s square plus 36, s square plus 36. So we can do, we can take the base common. S common means s square plus 36. So we can make the subtraction, right? Es minus 30. This is the value of Laplace. IU, what is that? 3, sorry. 3 cos 60. 360 minus 5 sine 60. This is the value of, now we need to do, we have to apply by applying first shifting theorem. What is the first shifting theorem? Laplace of e raised to at f of t is equal to bar of es minus a. So Now in this equation, what is the value of a raised to it? It's a plus, so we have to change in the sign only. So what I can tell you, in the equation what we have, a raised to minus 2t, right? So here we have minus sign, means we are going to make the changes in the s plus a. So instead of minus we are going to put plus, so s plus a. By applying first shifting theorem, what I need to do, what we have to put s is equal to s plus a, right? And value of a is 2 because e raised to minus 2t, so a is 2, right? So I need to put the value of s is equal to s plus 2. So what equation we have 3s minus 30 right here, 3s minus 30 upon s square plus 36. So for the simplification, 3 into s plus 2 minus 30 upon, right? S plus 2 square plus 36. To further simplify it, we need to multiply 3 into bracket 3s into 3 2, 3 into 2 6, 3s plus 3s plus 6 minus 30 upon s square plus 4s plus 4 is 36, right? What I will get here, after further simplification, I will get, sorry friends, some system got froze. I don't know. Okay, what I will get here, 3s plus 6 minus 30, 24, plus 24 minus 24. But I will get now for the simplification of this bracket, I will get s square plus 4s 4 plus 36 40. This is the value for Laplace of e raised to minus 2t into 3 cos of 60 plus minus, minus 5 sine of 60, right? So this is the answer for this equation. Go to next 6, right? What is the next example I can take? Okay, I will take two more example now. E raised to minus 3t into sine square t, right? Now we have to find Laplace for this. Laplace e raised to minus 3t in sine square, right? Now we have it's a first shifting theorem because here we can simply see that e raised to minus 3t term is there. So what we know for trigonometric, we have sine square theta is equal to 1 minus cos 2 theta upon. We have to apply this formula here. So what we will get here, instead of theta we have t, right? So we have Laplace of sine square t is equal to 1 minus cos of 2t on 2, right? Now what we need to do, I will take 1 by 2 as a constant outside, Laplace of 1 minus cos of 2t. We know the value of cos of 2t will be Laplace of cos 2t is upon s square plus square. So by 2 will be there. By applying linearity property, Laplace of 1 minus Laplace of cos 2, it, what I will get 1 by 2, 1 value of 1, Laplace of 1 is 1 upon s minus s upon s square plus a is 2 means 4, s square plus. If you want to further simplify it, you can do cross multiplication here. 1 by 2 s square plus 4 minus square s square upon s into s square plus 4. What I did cross multiplication this way. What I will get 1 by 2 s plus minus cancel upon s upon square plus 4. So what I will get 2 to 4, 4 will be 2 upon s upon s square plus 4. Now what we need to do, we have to apply first shifting theorem. By applying first shifting theorem. What is the first shifting theorem? Laplace of e raised to a t f of t is equal to f bar of s minus a, right? So in this situation now, what is the value we have? Here we have e raised to minus 3t, means minus term is there, right? So what I can do, I have to put a bar of s plus a. So I have to put s is equal to s plus a, right? Now what is the value of a here? 3, right? So I am going to put s plus 3. So Laplace of e raised to minus 2 3t sine square t is equal to 2 upon s plus 3 to bracket s plus 3 bracket square into, sorry, plus 4, right? So after further simplifying, what I can get, I will get 2 upon s plus 3, right? S square plus 6s plus 9 plus upon s plus 3 s square plus 6s plus 13 This is the value of Laplace e raised to minus 3t sine square t is equal to 2 upon s plus 3 to s square plus 6s plus 13. Now last example. Next example, cos of hyperbolic at into sine at. Now you will wonder, because I told you that whenever you see e into something, e raised to into something, then it will fall under the first shifting theorem. Now here you cannot see any e raised to term. So how you are going to solve this under first shifting theorem? So we have trigonometric formula for cos hyperbolic theta is equal to, right, e raised to a theta minus, sorry, it's a cos, so e raised to a theta plus e raised to minus a theta on 2, right? This is the value we have, cos hyperbolic function. So we are applying same here, right? What we need to do, plus of cos hyperbolic at in sine at. What I can write instead of cos hyperbolic at, I can write e raised to at plus e raised to minus at upon 2 into sine of at, right? So I will take 1 by 2 as a constant, Laplace of e raised to at plus e raised to minus at into sine of t, right? Now you can see if you multiply sine at inside this bracket, you will get 1 by 2 plus of e raised to at sine at plus e raised to minus at sine at, right? Now we know the value of sine at means Laplace of sine at is a upon s square plus s. At the same time, we have the formula in our scope now because it is a multiplied by e raised to. If it is a Laplace of e raised to at into f of t is equal to, you can write f bar of s minus a. Now in first term it's a plus sign, so we are going to put s minus a only. But in second term we have minus here, so we are going to put s plus a. So I'm directly doing this step, so you can simplify it like that. E raised to at sin at, sin at value is a upon s plus, sorry, a upon s square plus a square. So a upon s square s minus a bracket square plus a square, because I am directly putting value of s minus a at the place of s, because here we have plus 80 plus a upon a upon. Now here we have minus 80, so I am going to change only sin a upon s plus a bracket square plus a square is equal to 1 by 2. I will simplify it further. A upon s square minus 2as plus a square plus a square, right? Plus a upon s square plus 2as plus a square plus a square, right? So get further after simplifying it, 1 by 2 a upon s square minus 2as plus a square, right? That's a upon s square plus 2as plus a square. What we can do now here, if you want to further simplify it, you can simplify it by cross multiplying it, or if you want to put it as it is, then you can put it as it is, no any issue, right? So till this you are correct, or can close this as an answer. Laplace of, or in some book you can see it is of simplified in further way, or some book you can see this is answer. So what is the value of, we need to find out Laplace of cos of hyperbolic 80 sine 80. That's it. Now, now in next session we are going to in linearity property 2, sorry, property number 2. So if you have any doubt or anything which you want to discuss with me, you can mention me in the comment box so I can explain it to you further. So thank you. Thanks you. Bye.